This tutorial will prepare you for section 6.2 in your textbook, which covers solving systems of equations using matrices. During the course of this video, you're going to review how to solve systems using a method you've learned before, and then you're going to learn how to represent those systems with matrices. In class, I'll show you how to solve those systems. So first, let's remind ourselves, a system of equations means you have more than one equation, and you're looking for, in this case, an xy pair that will solve or satisfy both equations. And you've learned a couple of ways to solve systems. You could solve them by graphing, you could solve them by substitution. What I'm going to do here is solve this system using elimination. So I'd like coefficients of x or y to match, and since they don't, I'm going to multiply this top equation by 3. So everything in sight gets tripled, and now I have 12x minus 9y equals negative 9. And the bottom equation, I'm going to go ahead and multiply by 2. So I'm going to double everything, which would give me negative 12x plus 10y equals 7 times 2 is 14. The reason I did that is you'll notice that now the coefficients of x are 12 and negative 12. Since they're exact opposites, the best thing to do here is add the two equations together. 12 plus negative 12 is 0, so the x variable is eliminated. Negative 9y plus 10y, conveniently that's y, which is what we want to find. And negative 9 plus 14 is 5. So I'm halfway there. I know that y is 5. Now I need to find x. I find x by plugging my y value into either equation. I'll go ahead and use the top equation. 4x minus 3y is supposed to be negative 3. And I just figured out that y is 5. So 4x minus 15 equals negative 3. Adding 15 to both sides, I discover that 4x is 12, and therefore x is 3. So the ordered pair that satisfies both equations would be x is 3, y is 5. You can check that by plugging 3 and 5 in for x and y in both equations, and you'll discover that it works in both of them. So that's a quick review of how you would solve a system using elimination. That isn't new information, but I think it's worth reviewing that so that when you look at solving these systems using matrices, you will appreciate the power of using matrices to solve them. Okay, so here's how you represent a system using matrices. I'm going to take the coefficients and make a matrix out of them. So 4, negative 3. That's 4x minus 3y. And then for the second equation, the coefficients are negative 6 and positive 5. And then what I'm going to do is multiply those coefficients by the variables x, y. And if you remember how matrices multiply, you're going to multiply 4 and negative 3 by x and y, and you're going to get 4x minus 3y. And you know from the first equation that that's supposed to be negative 3. And then if you multiply this row by this column, you get negative 6x plus 5y, and you know that's supposed to be equal to 7. Okay, you'll learn in class how to take this representation using matrices, plug it into your calculator, and quickly solve the system. For now, I just want you to focus on representing the system using matrices, because that's a new skill and it's worth practicing. Okay, so for your homework, I've got two systems that I want you to solve. You can use any method you want. The method that I reviewed in this video was elimination. If you want to use substitution instead, that's fine. And then after you solve that, just represent the system using matrices. And in class, I'll show you how to then use those matrix representations to solve the equation. Please have this ready for class tomorrow. I'm realizing now that I didn't double check the number, so I hope homework number 6 is the correct number. All right, see you next time.